We're going to look at subsets. So given two sets, A and B, we say we say that A is a subset of B, and we write it A subset of B, okay? And the stroke order on that, the way I like to do it is I like to do a really, really long, it's like a U on its side. It's not a C. So that's stroke 1. And then stroke 2, after I've got that thing, like this. And let me show you what it's not. It's not that. It's not that. It's not that. Right? So I like to be really, really careful if I'm talking about set equality. Yeah, we'll come back to that in a second. So we say that A is a subset of B, and that's how we write it. So this means A subset of B. And this is true if and only if every element of A is also an element of B. When would A not be a subset of B? Under this definition, when would it be the case that A is not a subset of B? Yeah. We say A not a subset of B if, and only if, there is an X in A with what? Not an element of B. Okay? So we're going to do 2 more examples, then we'll talk about a proof mechanism, and then we'll wrap up. Nice job, y'all. What's that? We got 5 minutes, right?
Yeah.
Oh yeah, we got plenty of time. Welcome to the UC. Yep. It's a grind, right?
Yeah.
Yeah, it's brutal. You can do it. If I did it, you can do it better. My students are smarter, better dressed, better looking. The one thing I got is I'm a little older, so I got more gray hairs, right? You can do it. Okay, so let's take a look at this. L sub v, how's that related to L? What is L sub v again from our previous examples? Lowercase vowels. How's that related to L? Subset. Okay. U sub v, how's that related to U? Okay. What about L subset of L sub v? Since D is an element of L, but D is not an element of L sub v. In order to be a subset, everything in the smaller set has to be in the larger set. So a really, really nice visualization of subsets is what we call a Venn diagram. So if you want to visualize this, visual representation in a Venn diagram form, if you have a larger set B, and then A is strictly contained within B, we say that A is a subset of B. When would it not be that case? Yeah, so if we were to think about the visual representation, what would that look like? Yeah, so maybe, maybe we allow ourselves some creativity. Maybe there's just one element outside of that thing, right? Maybe I should just stick with circles. So here's B, here's A. some elements of A might be in B, but if there's just one element outside, we say that for sure A is not contained within B. Okay. Yeah. And then we got one more thing to do, and we got 2 minutes to do it. Don't you like the old Jeff better? I miss my old self. All right, direct proof of A subset of B. So, in order to do something called a direct proof of the proposition A subset of B, we're going to start with the same structure every time. So this is an outline or a template for direct proof of A subset of B. The first thing that we do is we say suppose, so we can make a conjecture, that the antecedent is true. And then if we've done our work well and A is indeed a subset of B, then at the end of the work that we do, we say, OK, if X is in A, X also must be in B. And then we conclude by definition, A is a subset of B. And then here, we say, I'll get there. We say that this is the work of math. Boom. Are you excited?
No, he's not really excited.
He's not excited? You seem excited. 35. So here's my question to you. When does a class end? Does it end at the stroke of midnight, or does it end at 59 after midnight? Because formally speaking, on the roll, it says 3:45, and my assumption is that it ends at 3:45 and 59 seconds.
Yes.
It's called the floor function, right? So formally speaking, I still had like 45 seconds left. You know what that's called? A mathematician using definition. Ooh! All right. So we finished. We'll warm up next time with an example of this, and I will see you again on Wednesday.